So each member of a group of 27 people was timed when completing a puzzle. The time taken X minutes for each member of the group was recorded, and these times are summarised in the following box and whisker plot. Part A says we need to find the range of the times, and this is for 1 mark. So to find the range of the times, what we're going to do is the highest value take away the lowest value, so the difference between them. And this is irrespective of whether we consider it an outlier or not. So for example, if we look up at the box and whisker plot up here, we're going to ignore whether it's included in this part here or one of these points out here. All we're going to do is take the highest value and subtract the lowest value from that. So up here we've got the highest value, which is up here. If we try and work out what point it is, so if we've got 60 here, then we're going to have 65 at this point here. So it's going to be 66, 67, 68. So this point here is 68, which is the highest value. And now we need to find the lowest value, and that's going to be the value here. So we know this one's 5. We're going to go 6, 7. So this is 7 here. So for the range, we're going to do 68, subtract 7, which gives us 61, and that is the final answer for 1 mark. Now for part B, we're doing something similar, but this time we're finding the interquartile range. Now the interquartile range is the difference between the upper quartile and the lower quartile. So the upper quartile, subtracting from that, the lower quartile. And here we're going to have a look at the box and whisker plot up here. And this line up here is known as the upper quartile, and this is the lower quartile. So these are the two values we need to find the difference between. So first we're going to work out what this value is. So if I label it here. Okay, so we've got 20 here, 30 here, and this is halfway, and it equals 25. And this part here is the lower quartile. And we see, okay, so we've got 10 here. This is 15. It's 1 before 15, and so it's going to be 14. So we've got the lower quartile equals 14. So then coming back down here to work out the interquartile range, 25, I'm going to subtract from that 14, which gives us 11, getting us another mark. Now for the next part, we're given some summary statistics. We're told that for 27 people, the summation of x is 607.5. The summation of x squared is 17,623.25. And part C says we need to calculate the mean time taken to complete the puzzle. And this is for 1 mark. Okay, so we've got the mean, and I'm going to represent that with the symbol here. We're going to say x bar to represent the mean. And the mean is everything added up divided by how many individual things there are. But we've actually got that data here, because if we look back up in the question, we see, okay, so we've got data for time taken in x minutes. So here, when they talk about the summation of x, this is essentially everything added up. So we've got 607.5, and we're going to divide that by how many things there are. So in this case, there are 27 people, which means there are 27 times. So essentially what we've done is we've got all the times added up together, which is 607.5. And we're going to divide that by how many times there are. And because there are 27 people, it means there are 27 different times. If we write this out in the calculator, that gives us 22.5. And we get 1 mark for getting the correct final answer. Now part D says we need to calculate the standard deviation of the times taken to complete the puzzle. And luckily we've got a formula here for the standard deviation. So this symbol represents the standard deviation. And the standard deviation is the square root of the summation of x squared, which is great because we're given that in the question, divided by n, and subtracting from that x bar, so the mean. And that's also great because we just worked that out, all squared. So we're going to do that to work out what the standard deviation is. And then here we've got a square root. We've got the summation of x squared. Well, we're given that up here. So I'm just going to write that in. And we're going to divide that by n. So in this case, n represents the number of things. So in this case, the number of different times recorded. And we worked out here that that's 27. So n is 27, so we're going to divide here by 27. Then we're going to subtract from that x bar squared. So we worked out here that's 22.5. We need to be really careful here and look at the brackets here, because we're going to square x bar and then we're going to subtract it. So it's important to do it that way around. So I'm going to write the brackets in here so it's still clear. So subtracting, and we're going to do this first. We've got 22.5 all squared. That's brilliant. I'm going to put that into the calculator, which gives us 12.10218 ... Now I'm going to round that to 1 decimal place and say that's okay, so that's 12.1 to 1 decimal place. And in this question we get 1 mark here. So if we get up to this part, so subbing in the values in. And then we get a second mark over here for getting all the way to the correct standard deviation. So next it says Tarunu defines an outlier as a value more than 3 standard deviations above the mean. Part E says we need to state how many outliers Tarunu will say there are in these data. giving a reason for your answer. And this is for 1 mark. So I'm going to focus in on this bit here where it says an outlier is defined as a value more than 3 standard deviations above the mean. So I'm going to write that a bit more mathematically here. I'm going to use our symbol x bar that we did earlier for the mean, and say more than 3 standard deviations above the mean. So I'm going to add 3, and again use our symbol for our standard deviation. And I'm going to work out what that is. So we've got the mean as 22.5. And we're going to add 3, multiply our standard deviation, which we worked out previously is 12.10218 ... And I'm going to put that into calculator to see what we get. And that gives us 58.8. If I round it to 1 decimal place. So now we need to think about the core of the question. We need to state how many outliers to Rooney would say there are in these data. So an outlier will be considered anything that is above 58.8. So I'm going to look back up to the diagram at the top, and we're going to find 58.8. So we've got 55, 6, 7, 8, anything around here. So this line is approximately 58.8. So we say, so therefore anything in this region is going to be classed as an outlier. So we're just kind of looking in the region and we see there's only 1 point in here. So all we have to say here is that therefore there's only 1 outlier. And doing that, we'll get 1 mark. So taking a look at the next part, we see Adam and Beth also completed the puzzle in A minutes and B minutes respectively, where A is greater than B. When their times are included with the data of the other 27 people, the median time increases, however the mean time doesn't change. Part F says we suggest a possible value for A and possible value for B, explaining how your values satisfy the above conditions. So firstly, the fact that the median increases implies that both values must be greater than 20. And we can see this by referring back to the diagram at the top. So we can see here the median is 20. And if we have one value that's greater than 20 and one value that's less than 20, well then the median is going to stay the same. Because it's sort of the middle number when you line all of them up. So it wouldn't make a difference. If you have both the values less than 20, then the median will go down. So you need both of them above 20, which means the median goes up. Okay, so now we dealt with the first bullet point here. We're going to have a look at the second bullet point. So that the mean time does not change. So we're going to use a variable. I'm going to say y. We're going to let y be the new total sum of times. So essentially the sum of the times when we're including the new values, so A minutes and B minutes within that sum of times. So when we do that, we're going to have y here. We're going to divide that by, and now because we had 27 before and we're adding 2 more times in, it's going to be 29. So this is how you work out the mean. Because we've got the sum of everything divided by how many there are. But we know that that doesn't change. We're going to set that equal to 22.5. So then from that, if we multiply both sides by 29, we can say that y equals 652.5. So continuing the work up here, we've got that the new total sum of times is 652.5. And what I'm going to do is I'm going to subtract the old total from that, because then we'll know what the sum of the new times are going to be. Because they're going to be making up the difference between the old sum and the new sum. So we've got the new sum, which is 652.5. And we're going to subtract from that 607.5, which we know is the old sum from part B. And putting that into the calculator, we get that the difference is 45. So therefore, what we conclude from that is that A plus B is going to have to equal 45. Okay, so I've just summarised everything we've worked out so far in this little box here. So we've got A plus B equals 45. A is greater than 20, B is greater than 20. And from in the question, it tells us that A is greater than B. Now we just need to find some possible values for A and B that could satisfy this. And there are a variety of different values you could have, so you can have a think about that. But the ones I've gone for is A is to be 24 and B to be 21. Because we know if we add these together, we'll get 45. They're both greater than 20 and A is greater than B. And looking through to see where we'll get the marks, we get 1 mark here for this line here. So working out that both values must be greater than 20. We get another mark for realising that A plus B is going to equal 45. And we get a final mark for writing down possible values for A and B. So lastly, we're going to look at part G, which says, without carrying out any further calculations, we need to explain why the standard deviation of all 29 times will be lower than your answer to part D. And this is for 1 mark. So if we have a think about this, we know that the mean from earlier on in one of the earlier parts, x bar, is 22.5. And we know as well from the previous part that the standard deviation is 12.1. So I'm going to do 22.5 plus 12.1, which gives us 34.6. and 22.5 minus 12.1, which gives us 10.4. Now if we have a think about this, if we look at these conditions, so A plus B equals 45, A and B have to be greater than 20, and A has to be greater than B. We know it's not going to be possible to find a value of A and a value of B that satisfy these conditions and greater than 34.6 or less than 10.4. If it was greater than 34.6, it would be more than one standard deviation away from the mean. Or if it was less than 10.4, it would also be more than one standard deviation away from the mean. But because of these conditions, it's going to have to be between 10.4 and 34.6. So basically it boils down to saying that both of the values A and B are going to definitely be within one standard deviation of the mean. Now the standard deviation measures the spread of the values. So if the values were outside of one standard deviation from the mean, then the standard deviation will be higher because the values will be more spread out. However, since we know they're going to be within one standard deviation of the mean, the standard deviation is actually going to be lower because the values are going to be less spread out. So essentially that's what the reasoning behind all of it. So I'm just going to write that out in sort of a succinct way that you need to write in order to get the marks. So I've written that both values will be less than one standard deviation from the mean. So the standard deviation of all values will be smaller.